Hello guys, welcome back to channel. So in today's video we will be solving LeetCode question 1769, minimum number of operation to move all balls to each box. So in the question statement is, you have n boxes, you are given a binary string boxes of length n, where boxes of I is 0 if the ith box is empty and 1 if it contains one ball. In one operation you can move one ball from a box to an adjacent box. Box I is the adjacent to box j if absolute of their indexes difference is 1, means the next index is exactly after that previous index, so those two numbers are said to be adjacent. Note that after doing so there may be more than one ball in some boxes. Return an array answer of n where answer I is minimum number of operation needed to move all the balls to ith box. Each answer I is calculated consisting the initial state of the boxes. So the question statement is very clear, but by looking at the constraint we can find that the brute force approach will not work. If we will run a n square loop, the time complexity will be 2000 into 2000, which will be exceeding the limit for the LeetCode question time. So how we will solve this question? Let's consider this example 0 0 0 0 1011. Before going to the example, I will explain you how this prefix array and suffix array concept work in this question. So in today previous video I also said you that prefix array question types are coming very frequently on LeetCode these days, so you should understand the full concept of prefix array and suffix array. So consider that we have an array 0 1 0 0 0 0, means we only have one in the entire entire array. So what will be the number of steps to move any ball to any index? So how we will find? Just suppose we want to find the number of operations we have to perform to move all the boxes to ith index. So in this case for 0 the next ball is at one distance from this, so the required move for this first index ball move from first index to 0 index will be 1 because it is exactly adjacent. But for the first index it is present at one index, so there will be not moves any. But for 2 it will be again 1. Then for 3 it will be previous moves plus how many moves we have moved from that previous index. So in this case that for 0 1 2 3, 3th index is at a 2 distance from the first index, so it can be calculated by going to the index of the 1, or we can just simply say that prefix of that number index and we can add current number in it. So it will be 1 plus 1 because we have to perform one extra move to move from that previous index to current index, so it will become 2. Then for 4th index it will be again previous plus how many index we have moved from that. For if we calculate like this 1 2 3, so we will get here 3, but we can also get it by previous plus how many moves we have made. So in this case we have moved 1, so it will be previous plus 1, then it will be same for all the cases. It can be so on. So why I explained you this? Because it is very necessary to understand the next steps we are going to do. So in this case we can say that the formula for every move of ith index, it can be given by prefix moves of I minus 1, that means the previous moves plus how many ones we have encountered. In this case we only have encountered one number of ones, so that's why it was always 1. But when we will take suppose an example like 0 1 0 0 1, so in this case for the first index it will be 0 moves because we did not have to move any one from left to this index. Now currently we are doing only left side one's transformation, then we will do right to transformation. So first let me explain how this will work. So in this case at 0 index there is not now any number of ones in the left of the array, so it will be 0. For 1 there will be not any number of ones we have to move from previous, so it will be again 0. But now we have encountered 1, so we will keep it in a count. So currently count will be equal to 1. Then for 0 1 2 we have moved, we will be using formula this because we have seen that for every index moving leftmost 0 to this index we just take the previous. In this case it is 0 plus number of ones we have encountered. In that case it was 1, so in this case it is currently again 1, so it will be 0 plus 1. Then for 4th index it will be again previous plus number of count, it will become 2. And in this case it will be count and plus previous, so it will be 3. For this index we only have to move this one to this index, so it is not considered. Now for suffix we can again use this formula, but in this case for suffix at the last index we does not have to move any 0 any number of 1 from right side of array, because it is 1. So and it is at last index, so there is not a single one we have to move at this index, so it will be 0. Now count is 0 for suffix index also, but when we will move to second last index, we have encountered a 1 previously, so it will become 1. Now we have one number of ones. For this second last index we will check how many moves we have to perform to move the last most index. So if formula will be same, moves of I will be previous of a moves of array and plus the current number of ones we have, so it will become 0 plus 1. So in this case it will become 1 and 0. Then for third last index it will be again previous plus current number of 0, so it will be 2. Then for third last index we have again, so at the 3th index from the last we will encounter an 1, so we will increase the count of the suffix, we will increase the suffix of count 2, because we have encountered again a 1. We have to move this one also from this index to this index, because previously all the moves we have already added in the prefix array, so means we have already counted the moves required to move all the ones to the this index. So for moving this all the number of ones to one step more, we will add the previous, which in this case will be 3, and the current number of 2, because we have to move in this first case when we have the one number of ones, we only have to add 1, because that one is going to be the next index of array was going to be moved. But in this case we have currently 2, so this will become 3 plus number of 2 we have to number of 1 we have to move. So in this case this will become 5 3 2 1 0. Now if we will take the summation of this previous prefix array and suffix array, so was right 4 3 3 3 and 3. So this is the answer we can calculate by prefix and suffix array calculations, and we can take this whole blocks to here, and then we can find that for prefix we have to move 0 steps from left, for this index we have to move 0, for this index 1, for this index 2, for this index 3, so it will be 0 0 1 2 3. And for suffix we have to move 0 steps from right, for this we have to move 1, for this we have to move 2, for this we have to move 1 2 3, and for this move we have to move prefix of this visual 3, and we have to move 1 1 from this index to this, and that previous one of count we have to move that also, so this will become 5 3 2 1 0. So the final answer is this. Let's code this. So first we will find int n is equal to boxes dot length, then we will create vector of int prefix, or we can say left, which will be of size n and its all value will be 0, and we will create a vector of int right whose also all values will be n, and we will create a vector of int answer, which will be sum of these two values, which will be also size n, and initially all values will be 0. Then we will start from for left, so we will keep left once, and its initial value will be equal to if boxes dot at 0, boxes dot at 0, if it is equal to 1, so we will take 1, else we will take 0, means if we have left ones is equal to 1. So in this case if we have left count like we have a string like this, so we have to consider this, that for 0th index it will not cause any problem, because in the left of this index there is not anything, so it will be 0. But for 1 we have to consider this, that there is a 1 at the 0, so we have to count that 1 for iterating over first index to last index. That's why we are keeping count of this, and we will start at ith index equal to 1, because for 0 there is not anything. If there is a 1, that will be also moves will be 0, because we cannot move the negative indexes array which is not present to the 0th index. That's why we will starting at 1, so it will be missing the 0th index number. That's why at the start we are considering if at a 0th index it is 1, so we will count that left ones. Then for int I is equal to 1, I less than n, I plus plus, we will do left of I is equal to left of I minus 1 previous plus number of left ones that we have to move left ones. And if boxes dot at I is equal to 1, we will add 1 in it, that we have to move one more 1, else we will add a 0. It will be making our left array. Then we will keep a right ones count, right ones which will be again same as this, because at the rightmost index there that same thing will happen, that we cannot move the rightmost array at the index because there is not anything present in this. But for if there is a 1, we have to consider that in the calculation, because we will be starting again at the 0, because it will be not considered, because if there is a 1 we will not do anything also, because it is at the end of the array, so we will miss this. That's why we are initially counting this, and we will start at n-2 for the calculation. So we will do for int I is equal to n-2, I greater than equal to 0, I minus minus, and we will do right of I is equal to right of I plus 1, because now we are counting suffix array. That's why, oh, there will be minus or there will be plus, and yeah, there will be rights 1, and we will do the same thing. If box at I is equal to 1, we will do right ones plus equal to this thing. If there is a 1, we will increase the number of ones, else we will not increase the number of ones in our calculation. So same here will be also, that left ones plus equal to boxes at I, and then we can just create for int I is equal to 0, I less than n, I plus plus, answer of I will be equal to left of I plus right of I. Then we can just simply return answer. It will work. Oh, right of I is equal to right of I plus 1, rights 1, D-R-I-G. Oh, spelling is wrong, rights ones. So yeah, it will work fine. 3, 2, 1, 0. Oh, at n-1 we are considering at last index, not first index for right, so it will be n-1, then it will give answer. And this is the most effective answer that could I come up with. First I was solving of this formula approach, which was like this, but it will be very complicated for you all to understand. That's why I designed this simpler formula by some research. And yeah, you can also join our Telegram channel. I will provide the link in description. I will be sharing the resource material how I come up with intuitions like this. So yeah, you can follow that also. So if you have any doubt, you can ask in comment section. Thanks for watching. Like and subscribe.